Welcome to division of complex numbers in polar form. The plan here is to prove division of complex numbers in polar form, prove the formula, and then do an example. So the formula says that if you have two complex numbers in polar form and you divide, it's really quite simple. You just divide the R values and then you subtract the angles. So we want to prove that that is not just magical, but there's really a mathematical reason behind it. So I'm going to start the proof with the initial statement. And then what I want to do is pretty typical with division problems and complex numbers. I want to multiply by the complex conjugate of the denominator. The one thing I'm not worried about at all is the R sub 1 over R sub 2, because that looks exactly the way we want it to. So I'm just going to multiply by the conjugate of the denominator of the stuff that's in parentheses, which is cosine theta sub 2 plus I sine theta sub 2 all over itself, but I didn't do the conjugate, did I? It should have been minus, because I want to change the middle sign. So the good news is I have my whiteout close at hand, and I'm going to fix that up. It should be the complex conjugate. So you change the sign in the middle. That is a minus sign. Nobody saw that. Okay, all fixed up. Now, I have R sub 1 over R sub 2, which is fine and dandy. The rest of the mess I need to FOIL, and then I will need to simplify. So in the numerator, I'm going to do cosine of theta sub 1, the first term, times cosine of theta sub 2, first term over here. Then we have the outers and the inners. It might actually work better if I do the inners first. I'm going to do I times sine of theta sub 1 times cosine theta sub 2 minus the outers, because I have this negative sign. It's going to be I sine of theta sub 2 times cosine theta sub 1. And then my last term, again, has a negative sign, and it's negative I squared sine of theta sub 1 sine of theta sub 2. Okay, hopefully I got the whole mess there. And now I'm ready to do the denominator. So the denominator, we're going to FOIL again. It's cosine of theta sub 2 times cosine of theta sub 2. That's first times first. Then the outer, negative I sine theta sub 2 cosine theta sub 2. And the inner, positive I sine theta sub 2 cosine theta sub 2. Notice anything right there? I think those are going to zero out. That's the nice thing about multiplying by a complex conjugate. And then the final term, last times last, is negative. Thank goodness for whiteout. It's negative I squared, so eventually it'll become positive, but negative I squared sine of theta sub 2 times another sine of theta sub 2. Okay, so made it through that. Now I want to look at what I have, both top and bottom, and maybe clean it up a lot, I hope. So I have cosine theta sub 1 times cosine theta sub 2. And I want to bring this term from the back end of the numerator. I want to bring it up front with this cosine business. So I have negative I squared. If I squared is negative 1, then that means we have the opposite of negative 1. So I have positive sine of theta sub 1 sine theta sub 2. That's this back term, the term at the top right of the numerator. And then I'm going to take the middle terms that both have I in them, and I'm factoring out the I. The leftover is sine of theta sub 1 cosine theta sub 2, And the minus sign is also left over. Sine of theta sub 2 times cosine theta sub 1. Okay, so we just cleaned up the numerator. And now we need to look at the denominator. The good news in the denominator is that these two middle terms are going to zero out. You have negative mess and positive mess, and it becomes a 0. So I'm left with cosine theta sub 2 times itself, which is cosine squared theta sub 2. And then over here I have negative I squared. Well, the opposite of I squared, that's the opposite of negative 1, is actually positive. And I have sine of theta sub 2 times itself, so it's squared. That's a very nice denominator. That makes me really happy. Next step. I have r sub 1 over r sub 2, which is not going to change because it's just the way I want it. And if you notice here, and you remember your trig identities, cosine theta sub 1 times cosine theta sub 2 plus sine of theta sub 1 times sine of theta sub 2 is cosine subtraction. So I am going to rewrite that as cosine of theta sub 1 minus theta sub 2. That's a simplified version of all of that. And then I have I, and this again is a trig identity. It's one we learned a few weeks ago. It's sine subtraction. When you have sine of A cosine B minus sine of B cosine A, that is sine. In this case, I know it's not A and B, it's theta sub 1 minus theta sub 2. But I think when we learned the identity, we learned it with A and B or X and Y, some other variables. And then this should be a trig identity that comes to mind, I hope. I think it's one of the first ones we learned. It's the Pythagorean identity. Sine squared theta plus cosine squared theta is 1. So that cleans up really nicely. I'll just rewrite it because we don't need the denominator at all. It's r sub 1 over r sub 2 times cosine of theta sub 1 minus theta sub 2. You subtract the angles, do the same thing again, theta sub 1 minus theta sub 2, and you divide the r values, and that's all there is to it. Subtract the angles, divide the r values. So now we're going to do an example with specific numbers instead of all the general variables. And I've just picked a random complex number in polar form and another one, complex number in polar form. The first thing we do is divide the r values. So on the front end, we're going to have a 5. Then the rest of it, we need to do a little subtraction. It's going to be 5 pi over 6 minus pi over 4. And then we have I sine, same angles, 5 pi over 6 minus pi over 4. Okay, so really that's it. I need my little closing bracket. And all we have to do is subtract our fractions. So we have a common denominator of 12. Both of these go into 12. So it's going to be 10 pi over 12 minus 3 pi over 12. And then we repeat the same thing. I sine 10 pi over 12 minus 3 pi over 12. Okay, just about done. We have 5 as our final r value, as the quotient r value. And we have cosine of 7 pi over 12 plus I sine 7 pi over 12. Thanks for watching.